They march in silence, mindless, obedient, and most terrifying of all, completely unaware they're already dead. But here's the twist. These aren't the undead from some post-apocalyptic horror movie. They're real. They're ants. And they're being controlled by a killer that doesn't need claws or teeth. Instead, it uses spores. This is the horrifying and absolutely true story of the fungus that turns ants into zombies, just to use their bodies as launchpads for death. But how does it control them? Could this ever happen to us, and why is something so small so brilliantly terrifying? Stay with me. This story gets wilder with every twist. Deep within the lush rainforests of Brazil, Thailand, and even Florida, something ancient thrives in the shadows. Not an animal, not a predator, but a fungus. Its name? Ophiocordyceps unilateralis. Sounds like a spell from Harry Potter, right? But make no mistake, this is real biology at its creepiest. Nicknamed the zombie ant fungus, it's a master manipulator that infects one particular group of ants, carpenter ants, from the tribe Camponatini. And once it gets in, there's no turning back. The spores land on the ant's body, stick, and slowly start to invade, using enzymes like chitinase and protease to break through the exoskeleton. From the outside, the ant still looks normal, for now. At first, the fungus lies in wait, but then it spreads like wildfire, not to the brain, as many assume, but into the muscle tissue. It builds a network, a scaffolding of fungal filaments directly into the ant's body. The result? The ant starts to convulse uncontrollably. It stumbles, it loses its way. Then, like a puppet with invisible strings, it leaves the safety of its colony and begins to climb. Why? Because the fungus is guiding it, literally. Scientists believe the fungus secretes chemicals like sphingosine and guanidinobutyric acid, both known to affect neural behavior. The goal? To get the ant exactly where the fungus wants it. Eventually, the ant reaches the perfect location, roughly 26 centimeters above the forest floor, often on the north side of a plant, where humidity hovers around 95%, ideal conditions for fungal growth. And then, it clamps down. The ant locks its jaws around a leaf vein. This isn't just a bite. It's the final act of a creature no longer in control. This behavior, known as the death grip, is irreversible. Muscle atrophy quickly sets in. The ant can't release even if it tried. And the fungus? It begins to feed. Over the next few days, it digests the ant from the inside, growing, building, and preparing for its final transformation. Roughly 4 to 10 days later, something grotesque happens. A dark, wiry stalk, known as a stroma, erupts from the ant's head. It's tipped with a spore-releasing structure called a perithecium. Congratulations, the fungus has completed its mission. From this stalk, new spores are launched into the air, raining death onto the forest floor below, where new ants might be exposed, infected, and controlled. But here's the catch. This isn't a one-off event. In some forest zones, up to 30 infected ant corpses can be found per square meter. These areas are literally called graveyards. So how did nature cook up something so disturbingly precise? Scientists believe this is one of the most dramatic examples of something called an extended phenotype, a phenomenon where a parasite controls the behavior of its host to increase its own evolutionary fitness. But Ophiocordyceps didn't just get lucky. Over millions of years, it evolved to infect specific species of ants. In fact, some O. unilateralis species can only infect one kind of ant and no other. This host-specific adaptation has led to over 20+ identified subspecies in just the last few years. It's not one fungus, it's a complex of killers, each fine-tuned to its victim. But evolution works both ways. Ant colonies have fought back. Infected ants are often detected and physically dragged away from the colony by their healthy nestmates. Some ants even groom each other to remove spores before infection sets in. In certain rainforests, colonies have adapted by staying in the high canopy, avoiding the forest floor where spores are most concentrated. But despite this, the fungus still wins, just slowly enough not to wipe out its hosts entirely. Think of it like nature's version of population control. As one scientist put it, it's like a chronic cold for ants. Here's where things get even stranger. Despite its zombie-like effects, researchers using fluorescent microscopy discovered that the fungus never even enters the ant's brain. So how does it control behavior? The answer seems to be through a combination of chemical manipulation and muscle hijacking. Fungal cells surround the muscles and literally rewire how they respond. The jaw-locking death grip? Caused by muscle atrophy, calcium depletion, and mitochondrial decay induced by the fungus. The ant isn't dead yet. It's being held hostage inside its own body. It's tempting to ask, if a fungus can do this to ants, could it evolve to do the same to us? Pop culture certainly thinks so. In The Last of Us, the entire apocalypse is triggered by a mutated strain of cordyceps infecting humans. The real-world basis? Ophiocordyceps unilateralis. But scientists say the leap from ants to humans is, thankfully, a massive one. Still, it is unsettling how many parasitic fungi and viruses can already manipulate behavior in insects, worms, even mammals. And let's not forget, one species of cordyceps has even replaced the gut bacteria of cicadas, allowing them to digest sap. Creepy? Very. But here's the curveball most people miss. This killer fungus is also a chemical factory. Researchers have identified multiple secondary metabolites it produces, some with antibacterial, anti-cancer, or immunomodulatory potential. Substances like polyketides and naphthoquinone derivatives from the fungus are now being studied for possible use in anti-malarial treatments, chemotherapy, antibiotic resistance, even food-safe dyes. The same organism that zombifies ants might one day save lives. But even the zombie fungus has enemies. In a wild twist, Ophiocordyceps can become infected by another fungus. A mysterious hyperparasite attacks its fruiting bodies before they release spores, rendering them non-viable. Only 6 to 7% of the stalks actually produce infectious spores. Scientists believe this natural check keeps the fungus from overwhelming ant populations completely. It's like a parasite of a parasite. Nature's dark circle of life, but perhaps the most haunting part isn't how it kills. It's how quietly it wins. Ophiocordyceps doesn't wage war, it doesn't make noise, it doesn't rush. It waits, watches, evolves in silence. It targets one ant, then another, slowly, precisely. It doesn't need an army, it just needs time. And through that time, it becomes a kind of ghost in the forest. You won't hear it, you won't see it. But the graveyards it leaves behind, they tell the story. Tens of lifeless ants locked in place, heads tilted, jaws clenched, each one a victim, each one a warning. Because in the game of survival, the loud don't always win. Sometimes it's the invisible that dominates. Ophiocordyceps unilateralis isn't just a marvel of evolution. It's a mirror into how power, control, and survival can take grotesque but genius forms in the natural world. It doesn't rage, it doesn't chase, it doesn't roar. It whispers, it waits, and then it takes over. One ant at a time. It's not the strongest that survive. It's the most cunning, even if that cunning comes in the form of a microscopic spore.